Hello, everyone, and welcome back to Michelle's version of calculus, where it may not be perfect, but it's good enough. And today, actually, we have a cute little calculus joke to warm us up. What do the calculus student who failed his test and the guy who got a speeding ticket have in common? They didn't know their limits. Ha 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 ha. I think that's a pretty solid joke. But today, as you can see, we're going to be doing Unit 1.7, Selecting Procedures with Limits. All right, so first thing first, we have rationalizing fractions with radicals. In case you don't remember, I have a little pink arrow here pointing to it for you, but radicals are those little square root house thingies, and you'll see them a lot. This little section of our unit should kind of be a review, just kind of going over once again more algebra that you should already know, but let us do our first practice problem together. All right, so here we have find the limit. Of course, it's x approaches 0 of our function here. As we can see, the numerator has a radical in it, and whenever we have this, at least with limits, you will want to multiply by its conjugate. So let's pick a cute little color here. Why don't we go with blue? All right, and the conjugate is basically like the flipped sign version of like the original thing that was there. So instead of having square root x plus 9 minus 3, you're going to change it to plus 3. And that will give you multiplying your conjugate, all right? And this is going to help you, it's going to help you get rid of this not so great square root, because as you can see, once again, we have a 0 here. And if you try to find the limit by, of course, plugging in this said 0, you will have an indeterminate, which is not what we want. So we're going to do this, and what you do to the top, you got to do to the bottom. X plus 9 plus 3. Cool, and we're going to do that. Ooh, make a little multiplication sign. It's not very clear. All right, so there you go. You're going to do this. All right, and I'm going to multiply this out for us. All right, so we're going to go ahead and multiply this. So, of course, erase this cute little arrow here. Hopefully you got the picture. All right, so of course I'll draw little arrows for you guys so you can actually kind of see what I'm kind of multiplying out here. All right, so square root of x plus 9 times square root of x plus 9, that cancels out the radical, and so you're going to be left with x plus 9 on your denominator. All right, so that one's done. Then you do 3 times x plus 9, so then you have plus 3 square root x plus 9. Alrighty, minus 3 square root x plus 9, square root x plus 9, It's 9. Alright, and that is all going to be over. It's our new numerator now. Alright, and we'll work on canceling everything out later. Oof, I almost forgot. Please, 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 always put your little lim sign. Alright, guys. College Board will deduct points for that, and I have also learned that the hard way. Alright, so we basically do the same thing with the x. You just got to go ahead and factor that all out. So x times x plus 9 plus 3x. Alright, cool. Alright, so now we're going to come down again. Let's keep your limb. Keep the limb here. Alright, okay, so let's get a new color. Let's go ahead and use red. And of course, we're going to go ahead and cancel out the terms that cancel out themselves. These beautiful things cancel, and we're going to be left with x over x square root x plus 9 plus 3x. Which is great. And then we're going to factor out the x. Let's just do that right here. Let's just pick a different color to make this a little less confusing. All right, let's go green. Or let's go orange. We're going to factor out this x at the bottom, so we're going to be able to cancel out the x from the numerator also. So plus 3, take that out. So now that we have that, we cancel. Okay, so now let's get our new, never forget to always write lim. Lim's x approaches 0. So, and also important, very important to note that there is always a 1 here. Do not put 0 when you cancel out the x's. There is an imaginary 1 in front of the x as a coefficient. Please do not put 0 or you will get the wrong answer. All right, so then we have 1. Oof, that's kind of like a 7. You have 1 over square root x plus 9 plus 3. And now we are ready to plug in our cute little 0 for, just 1, sorry. Plug in our 0 for x here. So when we do that, we get 1 square root of 9, which is 3, plus 3. All right, so then now you get the limit as x approaches 0 is 1/6. And that will be your final answer for that. Perfect.